Welcome to the June 2022 Edexcel IGCSE Paper 2H walkthrough. Cracking off with question number 1, we've got some integers. A is less than B is less than C is less than D. We know the mode is 9, so D is clearly 9. The median is 8, that will be halfway between C and D, so C is 7. The range is 4, that allows you to work out that A is 5, and finally 6 has to go in between them to complete the set. For the graphical inequalities, I'm going to plot the 3 lines, y equals 1, x equals 2, and x plus y equals 7. And I'm going to eliminate the areas that I don't want. You can test a point with this one if you like, or you can think about if you have y is greater than or equal to -1, you can eliminate all of the points where the y coordinate is less than 1. Anyway, once you've ruled out the 3 regions, you're left with the region R in the middle. Question 3, aeroplane travelling to New York. Just to make my life easier, 5 hours and 24 minutes, I'm writing as 5 and 24/60ths. It allows me to just type it into the calculator as a fraction within a fraction without having to convert it to a decimal. It comes out as 737 once you've done that. Question 4, be careful. This is a show that question. If you're missing any of the steps, you run the risk of losing marks because the answer is given. I'll turn them to top-heavy fractions, get myself a common denominator of 21, carry out the subtraction, and then simplify the final answer. Very straightforward, just make sure you don't skip steps out with a show that question. Alright, question number 5 is a compound shape. We've got a rectangle and a trapezium. By using a little bit of deduction, we can work out the width of the base of the trapezium is going to be 18, and the height of the trapezium is going to be 8. And so to find the area of the overall shape, we can find the area of the rectangle and then add the area of the trapezium. Obviously, the length CD is what we're aiming to find, so I shall leave CD as part of the formula, and the area sums to 434. Gives me a little equation. Up to you how you want to unravel it from here. You can simplify things, or you can bring stuff onto the right hand side quickly. There are many paths to get through this, and you can see the one I chose on this particular day right now. And we get CD as being 6.5 centimeters in length. Question 6, straightforward SOHCAHTOA. We have the adjacent and the hypotenuse. That x centimeters is adjacent to the angle. So cos adjacent hypotenuse, cos of 42 is x over 9.5, x equals 9.5 cos 42, which is 7.1 centimeters. Question 7, 81 kilometers per hour, so times it by 1,000 to turn it to meters, divide it by 3,600 to turn it into seconds, and we get 22.5 meters per second. Question number 8, so 300 celebration cards. First thing I do is sum 7, 5 and 3 to get 15. To work out the size of one part, we divide 300 by 15, so one part is worth 20. If I times 20 by 7, 5 and 3, we'll get 140 to 100 to 60 as the ratio. 2/5 of 140 is 56. So there's a total of 56 birthday cards with numbers. And then 0.36 of the anniversary cards, 0.36 times 100 is 36, which is the number of anniversary cards with numbers. If we add those two together, we'll get a total of 92 out of the 300 cards having numbers on them, and all that remains is to simplify. You can simplify in one step to 23 over 75 if you wish. Question number 9, straightforward compound interest question. Increasing something by 1.3%, you multiply by 1.013. I raise that to the power of 4 to do it 4 times. We get 52,651. Simultaneous equations question here. You've got all the choices in the world. I've gone for the elimination method. If you did it by substitution, that would be absolutely fine. I thought the simplest way to eliminate a variable is to eliminate y, because we can just multiply the second equation by 3, and we have the equivalent number of y's. Sum the two equations together, 16x equals 24, gives me the value of x being 3 over 2, and then substitute that into any of the equations above with a y in it and solve it to get that y equals negative 5 over 2. So 1.5 and minus 2.5. Factorising x squared plus 5x minus 24, x plus 8, x minus 3, and therefore x is equal to minus 8 or plus 3. Question 12, Larry, our delivery man. We know that the mean weight of the 7 parcels is 2.7, so if I do 7 times 2.7, it gives me the total weight of those parcels. Similarly, we know 4 parcels at 3.3, so 4 times 3.3 gives the total weight of those parcels. Work out how much is left. There's 5.7 kilograms left. Divide that by the 3 remaining parcels, meaning they have a mean of 1.9 kilograms. Okay, cumulative frequency, so I'm just adding each number as I go up. So 7 is still 7, add 25, and then add 20, and then add 14, and 8, and 6. To plot the cumulative frequency diagram, I plot each point at the end of the class width. That's the most common mistake, is plotting at the wrong spot. So I'm plotting it at 20, 30, 40, 50, 60 and 70. And then I'm going to draw a line going through those. For cumulative frequency, you can draw a freehand line, or you can do it by straight line segments. The dot-to-dot approach is the only time when you can do a dot-to-dot approach, really. Here's my my effort, which is close enough. Alright, to find the median age of the 80 people, well, there's 80 people, so the median is at 40. We can read that off, 34. And then to find the number for D, we'll plot the 2 lines going up and across. And we'll get 77 and 7, gives me a total of 70. And I'm going to times that 70 by 0.6 to find 60% of them, which comes out as 42. There is a little bit of margin for error on these questions. Question number 14, expand and simplify. You can expand the first 2 brackets together and then multiply it by the third, or you can do the second and third and multiply it by the first, or indeed you can do the first and the third and multiply it by the second. It doesn't really matter. I've done the second and third, expanded those out, and then I've multiplied each component by the values in the first bracket and collected them together, giving me minus 2x cubed minus x squared plus 43x plus 60. And there's my answer. For B, to make C the subject, what I'm going to do is I'm going to add 7 to both sides as my first step, just to get that 7 out of the way. then we have a c trapped in the denominator of the fraction, so I'm going to multiply by 4 plus c to untrap it. So both sides got multiplied by 4 plus c there. Now I'm going to expand out the left hand side, 4g plus cg plus 7c plus 28. And then I am going to collect all the terms that involve a c in on the left hand side and all of the terms that do not involve a c on the right hand side. And I'm going to factorize the c out. So c lots of g plus 6 equals minus 4g minus 25. And lastly, just divide by g plus 6. We get minus 4g minus 25 over g plus 6. And we can see c is the subject. For 15 algebraic fractions, we have numerical denominators, so this is one of the more straightforward ones. First thing I'm going to do is get a common denominator before subtracting them. The denominator I'm going for is 6, the lowest common multiple of 2 and 3. Now just be careful when you're carrying out the subtraction of the numerators. You are doing 8x subtract negative 6x, which comes out as 14x. I wonder how many of you wrote 2x. The rest is straightforward, times by 6, subtract 1, divide by 14, and we get the final answer of 11 over 2, or 5.5. For b, I'm going to factorise the inequality, 2y plus 5 and y minus 6, which is less than or equal to 0. Here you have some choices. I'm just going to do a little picture to show you what I was thinking at this point in time. So we've got a smiley face quadratic going through the two critical points, minus 2.5 and 6. And now we want when is that below the x-axis? When is that negative? When is that less than or equal to 0? Well, that's in between those two critical values. So my solution is negative 2.5 is less than or equal to y is less than or equal to 6 for the final answer. For the Venn diagrams, this is a little logic puzzle. We know that 6 have goats, sheep and chickens, so the first thing I'm going to do is write 6 in the middle of those 3. Then we know that 11 have sheep and goats, so there's got to be a 5 above the 6 to make that intersection total 11. And I just working out using that sort of logic the remaining bits of information. And we're going to do a little calculation at the very end, just to find out that remaining value. Alright, the number of elements in G, so sum those in G, that's 36 in there. The number of elements in G union S complements, so G union S, that's goats and sheep complements, so that's 24 and the 20. The number of elements in G complement intersects C is 35. And then finally, the conditional probability 18 over 53. Right, so m varies directly as the cube of h. M is directly proportional to h cubed if you prefer. Replace the proportional symbol with an equals k, where k is a constant of proportionality. Substitute 4 and 0.5 into that to find that k equals 32. Therefore, we can write that m is equal to 32 times by h cubed. And all I'm going to do is unravel that, substitute in m to be 500, divide by 32, cube root it, we get a value of h, which is 5 over 2, or 2.5. For question number 18, this is a bounds question. Whenever I get a bounds question, the first thing I tend to do is to write the upper and lower bound for each one of the variables. I do this for two reasons. Well, it allows me to think about which one I'm selecting when I'm doing the calculation, but it's also worth some marks, so it never does any harm. The upper bound for A is 7.55. The lower bound for A is 7.45. And I do that for the other Then to find the upper bound for x, we want to take two lots of the upper bound for a, I want that to be as big as possible, subtract the lower bound for b, I want that to be as small as possible, and divide by the lower bound of f, because I want that to be as small as possible. So 2.755 subtract 3.415 over 1.5 comes out as 7.79. Question 18. Question 19. So we're going to substitute the x that's in the first expression for what x is equal to in the second. It's going to give us a fraction within a fraction. There's a few ways of dealing with this. I've gone for multiplying by a fraction equivalent to 1 that will remove the fractions in the denominator. So I'm going to multiply by 4y minus 3 over 4y minus 3. And that's going to cancel with the 4y minus 3 underneath the 7 in the denominator. So the numerator becomes 14 lots of 4y minus 3. That's a straightforward multiplication. The denominator, well, in the first part of it, 3 lots of 7 over 4y minus 3, that will just cancel the 4y minus 3's, leaving me with 3 times 7, and then subtract, and then I have to times that 7 by the 4y minus 3. Now we've got rid of all of the fractions within fractions. All that remains to do is to expand everything out, collect like terms, and then simplify if we can. That denominator has got a common factor of 14, so I can factorise the denominator and cancel down the fraction, cancel the 14's, leaving me with 4y minus 3 over 3 minus 2y. Question 20. We're going to construct an expression for the shaded area. To do that, I'm going to find the area of the whole square, where there are 4 radii taking me from one side of the square to the other. So the side length of the square is 4r, so 4r squared for the area of the square. Subtract the 4 circles, that's 4 lots of pi r squared, will give me the shaded region, which the question tells us is 40. 4r all squared is 16r squared, subtract 4 pi r squared is 40, and divide everything by 4. And then I'm going to factorise out an r squared. So r squared lots of 4 minus pi will be equal to 10. If I divide both sides by 4 minus pi, we'll get that r squared is 10 over 4 minus pi, and square root both sides. Therefore, the perimeter of the square is going to be 16 lots of those radii, so 16 lots of the square root of 10 over 4 minus pi, which is 54.6 centimetres. Question number 21 is one of the tricky vectors questions. I'm going to start by using some of the information they've given me. So AP is equal to AO plus OP. In the question it tells us that A to P is 2A plus 8B. And that will be therefore equal to minus 4a plus o to p. Adding 4a to both sides, we can deduce that o to p is 6a plus 8b. Now the key to unlocking this question is by constructing the vector a to q in 2 different ways. The first way I'm going to construct a to q is by saying it's a proportion of a to b. To turn that into mathematics, a to q equals lambda a to b. We know that lambda is going to come out as a fraction, therefore. We have the vector a to b, it's minus 4a plus 6b, so lambda a to b is lambda lots of minus 4a plus 6b, and I'm going to expand that out to make 4 lambda a plus 6 lambda b. The alternative way of going from a to q is to go from a to o and then from o to q. Going from a to o is trivial, it's minus 4a, and then we're going to go a proportion of a to p, because OQ sits on the line OQP. So I'm going to call that proportion of O to P mu lots of 6a plus 8b, where mu is obviously some sort of fraction. I'm going to expand that and then factorise. So the number of little a's we've got is 6 mu minus 4, and the number of little b's is 8 mu. And I know that the two different ways that I've constructed the vector AQ must be equal to each other. So if you like, the coefficient of a's must be the same and the coefficients of b's must be the same, and that gives me two simultaneous equations. 6 mu minus 4 equals minus 4 lambda, and 8 mu equals 6 lambda. That allows me to work out that mu is equal to 3/4 of lambda. Substituting that in to the first equation, 6 times 3/4 lambda minus 4 equals minus 4 lambda. Go on to solve it, we get lambda equals 8 over 17, and that's enough to deduce that a to q is 8/17 of a to b, i.e. a to q to b must be split in the ratio of 8 to 9. If you think about it, if it's 8/17 of the way, then there's 9/17 left over. So a to q to b is 8 to 9. Well done if you got that. Question 22, the coordinate geometry question with the kite. With all of the coordinate geometry questions, I strongly recommend drawing a little sketch, and your sketch is welcome to be just as terrible as mine is. It's probably not quite mathematically accurate, it's not precise, but it allows me to think about what it is I need to do in order to solve the problem. So I'm going to plot A, B, C and D. We've got the point M, the midpoint, with the coordinates 0, 2, and we know that AB is equal to AD and that they are both 6.5. Okay, the gradient of the line passing through A and M, well, we have the coordinates of A and M, so we can use the formulas. 4 minus 2 over minus 3 minus 0 gives us a gradient of minus 2/3 for the line passing through A to M. Therefore, the gradient of B to D is perpendicular to that gradient, so it's a negative reciprocal, comes out as 3 over 2. And now I'm going to construct the equation of the line BD. We know the gradient is 3 over 2. It passes through 0, 2, so that's going to be the intersect with the y-axis. I actually have to do very little work there. Y equals 3 over 2x plus 2 is the equation of the line BD. Now the point B, we know sits on that line, so I'm going to give it an x coordinate of x and a y coordinate of 3 over 2x plus 2. I know that because it sits on the line y equals 3 over 2x plus 2. We know that the distance from the point A to the point B is 6.5 or 13 over 2. And so if I use the formula for finding the distance between 2 points and use my, well, we know what A is, and use my x and 3 over 2x plus 2 for B, it allows us to construct an equation. So I'm going to square both sides here and expand everything out, as you can see. At this point I'm thinking, alright, I've got 169 over 4, it's quite a messy fraction. It may simplify things here if I multiply everything by 4. That will also cancel out the 9 over 4x squared. So I'm just working with integers from now on. Largest power of x here is 2, so it's quite clear that this is a quadratic equation. However, this is one of those quadratic equations where the coefficient of x, if you like the bx, is 0. There are no x terms. So I could equate it to 0, factorize and so on, but actually here I've decided I'm just going to solve it by sort of isolating the x and doing it. And we get an x coordinate of 9. Sorry, x squared is 9, therefore we get 2x coordinates plus or minus 3. Plug those back into the equation of the line BD, and we get y coordinates of 13 over 2 and negative 5 over 2. And those are the two pairs of coordinates for this question. Those would be my B and my D. There you go. Okay, question 23. The coordinate point A. Well, just plot this on your calculator. 180, 0 for the x coordinate. If you don't already know the graph, you can just plot it on your calculator. And then for the point B, that minimum point there, it's 360, negative 1. Again, you can use the gsolve function if you have a GDC. Question 24, the indices one. The key to spotting what to do here is to write everything as powers of 2 and 3. So 18 is the same as 2 times 3 squared. The square root of 27 is the same as 3 to the power of 3 over 2. 6 is 2 times 3, and 9 is 3 squared. And I'm just going to make that 3 squared into 4n plus 3 to the power of 4n plus 16. Cancel the 2's straight away. I'm cancelling 3 as well. Expanding out the powers, something to the power, something to the power, something else. We can multiply the two powers. Next, I'm going to bring that 3 in the numerator up, so adding 1 to the power of the other 3. And finally, carrying out subtraction of the powers, we'll get 3 to the power of 2n minus 6, which it tells us in the question is equal to 3x. Therefore, x is equal to 2n minus 6. Well done. Bye.